Hello everyone, welcome to Algebra 1 with Miss Betsy. I'm glad you've joined us today. What we're going to be talking about today is the slope of a line. How do you calculate? What is it? How do you calculate it? Why is it important? If you are using the same text that I am, we are in Algebra 1 for Christian Schools, published by Bob Jones University Press. I'm using the second edition, section 6.5, and we are on page 238. You don't have to be using our same text at all. Slope of a line is slope of a line no matter what text you're using. Before we begin, though, I have another piggy riddle for you. This is actually the second time that I started this video. I actually got my tongue tied so badly last time I had to start it over. This is probably one of the lamest jokes I've ever told, and there's quite a few out there I think that are vying for this. What do you get when you cross a pig and a canary? Well, you get something really ugly. Look at that picture that they've drawn there. What do you get when you cross a pig and a canary? You get a hummingbird. So, anyway, we're on page 238. I'm going to be referring to the book a whole lot here because there's just a lot of reading, and some of y'all are having a hard time comprehending the math and having it make sense to you. So I want to go ahead and go through part of this text. But when I mentioned that we were talking about slope of lines, those of you who are skiers, particularly downhill skiers, when you think of slope, you're immediately going to think of the slope of your ski run. Now, I'm not a skier. I can get to the bottom of the hill just like anybody else can, but it's not going to be on my skis. It's going to be me rolling down the hill. But you know as a skier, and you know just as an intelligent human being, that the steeper your slope is, the faster you're going to get to the bottom of the hill. You know, if you're going down a hill that steep, or down a hill that steep, you're just going to have a nice gentle roll down this hill. You're just going to go to the bottom when you have a steeper hill. And slope tells us how steep a hill is. So what I have sketched for you here is an example, just a picture representing a bunny hill at your ski resort. The top of the hill is represented by point A. The bottom of the hill is represented by point B. When you're at the top of your bunny hill, you're 2 units up. You're 2 units high. By the time you get to the bottom of the hill, you're back down here to 0. So you've gone from 2 down to 0. So what we call your vertical change is a -2. Let's think about this. On our Cartesian coordinate system, our y-axis is the one that's vertical, isn't it? And what happens when you move up on the y-axis? It's a positive change. You move down on the y-axis, it's a negative change. And this is what we're talking about here. We've moved down vertically, so it's a negative change. Our vertical change is negative. A negative vertical change means you're descending. You're going down. And our horizontal change is going to be a +12, and that fits with our graph as well. We have our x-axis on our Cartesian coordinate system. If you're going to the right, you're moving in a positive direction. If you move to the left, you're moving on in a negative direction. So our change here vertically, we've gone down 2, so it's a -2. We've moved to the right 12 units, so our horizontal change is a +12. And wrist is still sprained. And I'm going to find that all slope is, it's a relationship between the vertical change and the horizontal change. Horizontal change. So what did we say that our vertical change is? Or what is our vertical change? Just reading this. If this is 2 units high, by the time we get to the bottom of the hill, we have gone down 2 units. So our vertical change is a -2. Our horizontal change, starting from 0 and going to 12, is a +12. So our slope is a -1/6. Now, I don't know if this is true on ski slopes, because I don't ski, but I do know that it's true up in the Northeast and Colorado, those places where you do have steep inclines. Sometimes it'll say, caution steep incline or 7% grade. The grade, 7%, what they're talking about there is just a measure of the slope. So if we were to actually go ahead and change this to do this division here, this would, 1 divided by 6 is approximately 17%. This is a -17%. And what this tells us is that we have a downgrade, a 17% downgrade, which is pretty significant. You don't do those on a car very frequently at all. The negative is important. See, we're starting high, we're going down. So a negative slope is a downgrade. A positive slope is an upgrade. Okay, if your slope is negative, you're going downhill. If your slope is positive, you're going uphill. So let me go ahead and erase this and read this definition to you and talk about it. And I'm not going to expect you to spit out word for word this definition, but you have to understand what it is. Page 238 says the slope of a line is the change in the y values of 2 points divided by the change in the corresponding x values of those 2 points. The vertical change or the rise divided by the horizontal change or the run. Okay, we're going to come back and we're going to talk more about vertical change, horizontal change, rise, and run. And you'll learn that those are just alternative ways of describing how steeply your hill, your line slants downward, how rapidly your line moves in an upward direction. So we've got a formula here that they want us to use first of all, and this is the formula for slope. And this you do need to memorize. It says m is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1 if x sub 2 minus x sub 1 is different from 0. M is always going to represent slope. When we're talking about equations of a line, slope is always going to be m. Why they picked m? Not really sure. I think it goes back to a Latin word. I can't pull that from my memory right now. I read this as y sub 2, y sub 1, x sub 2, and x sub 1. That's because these are just subscripts. If that's y to the 2nd, y to the 10th, y sub 2, y sub 10. It's just how you read numbers that have superscripts and subscripts on them. And what the slope is, this is the slope of a line passing through 2 points. Excuse me. Slope of a line passing through 2 points, and how are we going to identify these points? X sub 1, y sub 1, x sub 2, y sub 2. M is the slope of a line passing through 2 specific points. This is once again where we're just using some algebraic notation. Can look confusing at first until you get used to what they're talking about, but they're just saying when you want to find the slope of a line, you've got 2 points, you're going to have an x value and you're going to have a y value for each point. Subtract the x values, divide that by your difference that you get when you subtract the y values. I'm sorry, you subtract your y values divided by the difference of the x values. Let me go ahead and show you exactly what I mean. This is nothing to be afraid of at all. Example number 1 says, find the slope of the line that passes through the points 1, 4, and 2, 2. I'm going to go ahead and erase our definition of slope, but remember that m is the slope of a line that passes through 2 points. And I do want to make sure that you see that x sub 2 minus x sub 1, the difference of the x values, can't be equal to 0. And why is it that it can't be equal to 0? Yeah, of course, you can't divide anything by 0. So we have 2 points on a line. We have a point 1, 4 and 2, 2. And I'm going to go ahead and take just a moment here. I did not draw a grid to begin with for you. Let me go ahead and sketch a graph. When I began this video, I thought I really don't need to have a grid, so I didn't make one. And now as I'm teaching through it again, I think I want to do that anyway. 1, 2, 3, 4. I apologize that I don't have this a little bit more neat. Okay, and I'm just going to go ahead and graph this 1, 2, 3, 4. Draw our straight line, so that I can actually show you how slope is working. We go ahead and label a couple of points here for you. X is 3 and y is 0. X is 1 and y is 2. I'm sorry, x is 2 and y is 2. X is 1 and y is 4, x is 0, and y is 6. So let's look and see what we have going on here. What we want to do is follow the vertical change in y. What we're doing is just seeing what happens as we go down the slope. Let's say that we start at this point, 1, 4. It says if you're going to move to the point 2, 2, how far down do you have to move? Remember our picture from the very beginning? Let me sketch this for you. Our bunny slope. We went down 2 units, and we went to the right 12 units. Because the top of our bunny hill, we were at 2 units above. By the time we got to the bottom, we were back to 0, so our vertical change was a -2. And our horizontal change is a +12, and that's all we're going to do as we walk through this problem here. start at 1, 1, and by the time that you get to 2, 2, how many units have you changed? You've gone down 1 unit, 2 units, right? So our vertical change right there is going to be a negative 2. What's our horizontal change? Well, we've moved from 1 to 2, so the horizontal change right here is just a positive 1. So the slope of the line is the change in the vertical distance, which is a negative 2, divided by the change in the horizontal distance, which is a positive 1. So our slope of this line is a negative 2. Do not change the slope into a percentage form. We only did that percentage form to illustrate that grade of a road or of a ski slope is actually slope put into a percent form. Here we have the slope of the line is simply a negative 2. We said that the slope of the line was the change in the vertical change divided by the horizontal change. It can be called the change in the rise divided by the run. And we can use our little formula, which we have right here, which I'm going to show you in just a minute. Okay? To get from point 1,4 to point 2,2, you've gone down 2 units, which is a negative 2. You've gone over 1 unit to the right, which is a positive 1. The slope is the vertical change divided by the horizontal change. Well, what happens if we want to use 2 different points? Let me go ahead and write a couple different ways to say this. This is the rise divided by the run, and it's also the vertical change divided by the horizontal change. That little up and down arrow, back and forth arrow, just means our change in y. Change in, is it a negative change? Is it a positive change? Is it going up or down? Is it moving to the left or the right? And we chose to determine that this slope was a negative 2 when we use these 2 points. Well, what happens if we picked 2 different points? Well, what if we went from the point 0,6 to the point 2,2? We've gone down twice as far, haven't we? Shouldn't it make sense, maybe, that if our slope to begin with was a negative 2, since we're going twice as far, is the slope maybe going to be a negative 4? Well, let's see what happens. How exactly are we going to calculate slope? We're going to say that the slope is our vertical change divided by our horizontal change. Now to get from here to here, what's our change? Well, we started at 0, we've started at 6, we've gone down to 2, so we've gone down 1, 2, 3, 4. Because we're descending, that's a negative vertical change. We've gone down negative 4 units. What's our horizontal change? Well, we have progressed from 0 to 2, 1, 2. In the right-hand direction, in the positive direction, so our horizontal change is a positive 2. We divide our vertical change, which is called the rise, by our horizontal change, which is called the run, and lo and behold, we have exactly the same slope. And that's because slope is the same no matter what the length is that we're calculating it, because you've got proportionality going on here. Your slope is never going to change. Well, okay, we started up here at the top of the hill, and we went down to the bottom of the hill. So of course we got a negative slope. But what happens, because we know we're going downhill, if we have a negative, that means that the slant of our line is going downhill. But what would have happened if we went up the hill? Should be a positive slope, shouldn't it? If I start here at the point 3, 0, and I end up at the point 1, 4, I'm climbing up that hill. So it ought to be a positive. What do you think? Well, let's see what happens. If we go from the point 3, 0 over to the point 1, 4, up and down, that's our vertical change, isn't it? Before, we had a negative vertical change because it was coming down. Now, however, we have a positive vertical change from 0 to 4. So our vertical change is a +4. Sure looks like we're going to get a positive slope. And Miss Betsy, you just said slope is always the same. Well, what about our horizontal slope? Look at what direction we're traveling. We're traveling to the left in a horizontal direction, so that's a negative change that we have. Moving from 3 to 2 to 1. So our run, or our horizontal change, is a negative. So now, slope is the rise over the run, or the change in y, the vertical change divided by the horizontal change. Our vertical change is a +4. Our horizontal change is a -2. And sure enough, the slope is the same. That's because slope is consistent. Because yes, we are going up the hill from here, but when you're determining on a graph if a line is descending or if it's ascending, that has a negative slope or a positive slope, you read the graph starting at the left. So here, we're clearly going downhill. You can calculate slope, just like we did by climbing back up this hill, but you're starting at the bottom of the hill. The slope of the line is read and calculated by you looking at the line from left to right, if that makes any sense to you. Okay, that was example 1. Let's go ahead and see some more of what they're showing us. Lines with negative slopes are going downhill. Here are some examples of some lines that have negative slopes. Here are some examples of lines that have positive slopes. How do you tell the difference? As you move from left to right on your y-axis, if the line moves down, that's a negative slope because that line is dropping. As you move from left to right on the y-axis, if your line goes up, those lines have a positive slope because the line is increasing. Okay? There are different ways that you can describe what the slope of a line is, and you need to be able to recognize all of these as different ways of saying the same thing. Write these down, memorize them, know what they mean. Slope can be m, slope can be vertical change over horizontal change. Over horizontal change. Now what can it be? It can be change in y divided by change in x. divided by the change in x. They can refer to it as rise over run. They can refer to it as the difference of the x coordinates of 2 points divided, I'm sorry, I did that again. The difference of the y coordinates of 2 points divided by the difference of the x coordinates of 2 points. Change in y over change in x, that's the same thing as delta y over delta x. That triangle is the Greek letter delta, and when you talk about a delta in math or science, you're talking about change. Now you have the Nile Delta, which is the Mississippi Delta, where it's very rich soil that's been deposited at the mouth of a river. That's not the delta we're talking about. We're just specifically talking about a Greek delta, and all that means is the change. The change in y, are we having a positive change because we're going up? Having a negative change because we're going down. This vertical change over horizontal change, you'll see me just use as quick shorthand. Arrows up and down, arrows left and right. And it's important, slope is not the horizontal change over the vertical change, it's the vertical change over the horizontal change. Now we're going to actually go ahead and use our y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And you'll see that even though that sounds like a bunch of gobbledygook coming out of my mouth, that's very straightforward. We have these 2 points, 4, 1, and 2, negative 3. What does our formula tell us? It tells us that the slope of a line is the change in y divided by the change in x, or the difference of the y coordinates of 2 points divided by the difference of the x coordinates of 2 points. So what happens, how do we know which is point 1 and which is point 2? So we're going to just define 4.1, for 1 to be point 1, in the ordered pair 2, negative 3 to be point 2. So that means, all this means, is to calculate the slope, we're going to take the y value of the second point, negative 3, minus the y value of the first point, and we're going to divide that, the x value of the second point, minus the y value, the x value of the second point, minus the x value of the first point. So slope is negative 4 divided by negative 2, so the slope is going to be a positive 2. That's all you have to do. Well, you know what? I know easily what y'all are thinking right now. Got a couple names in mind here for you to think about. Miss Betsy, what if I wanted different points to be point 1 and point 2? So let's see what happens. Let's say that we have 2, negative 3 as point 1, and we have 4, 1 as point 2. Now we better make sure this is working right. So our slope is the difference of the y values divided by the difference of the x values. What is our y coordinate of our second point? Well, the y coordinate of our second point is 1 minus the y coordinate of the first point. That's a 1 minus a negative 3. What about our x's? The x coordinate of the second point minus the x-coordinate of the first point. We've got a negative 3 minus 1 gave us a negative 4. 1 minus the negative 3 gives us a positive 4. We got a problem going on, don't we? No, you don't have a problem going on at all. You have 4 divided by a negative 2, so that you have a slope of negative 2. It doesn't matter at all which point you call point 1 and which point you call point 2. What does matter, however, is once you've identified a point as point 2, you can't go back and forth. You can't say, okay, I'm going to take this y value and subtract that y value, this x value and subtract a different y value. You can't switch them around. You have to be consistent as to, this is the second value of my y coordinate, this has to be the second value of my x coordinate. I can't have second value of the y, second value of the x. They have to both come from the same point. You understand what I'm saying? This is all that's involved in calculating the slope of a line. When you have been given 2 points, it's very, very, very easy. Cannot be any easier than this. Only thing that's going to jump out and bite you, if you're not careful, is you'll drop negative signs, or you'll do some arithmetic incorrectly. We have the slope of a line passing through the points 3, 4 and negative 1, 5. 3, 4 and negative 1, 5. The slope is is the y coordinate subtracted divided by the x coordinates subtracted. Something that I like to do, I just automatically begin with the first point. So I'm actually labeling my points this way, point 2 and point 1, because it's a way that my mind works a little better. 4 minus a negative 1, make sure that you're using your parentheses, in particular when you're substituting in negative numbers. 3. Okay, do you see what I did? 4 minus a negative 1. I said, oh, let's take the second y value, subtract the first x value. How many of you caught that? Good for you if you did. Shame on you if you didn't. Wake up. I'm the only one that's allowed to be sleeping here. The y value, 4 minus 5. And you know what I did? The reason I said 4 minus a negative 1 is my mind's always several steps ahead, because 4 minus 5 is a negative 1. But you have to go slowly enough to make sure that you're doing your substitution properly. Now we're going to subtract our x values, 3 minus a negative 1. Our slope, negative 1 divided by 4. So our slope is a negative 1/4. Do I care if you have your negative 1 in the numerator or out in front of the fraction? No, don't care at all. These are the same thing. It's all that's involved in finding the slope of a line. See how easy it is? That was example 3 on page 240. Now, they're still giving us some more lines. And that's because some more slopes to do. And that's because we have 2 specific definitions that we want to get into. You notice that what we've done so far is we've had lines that are clearly descending or ascending. What happens if we have the slope of a horizontal line? Now let me just go ahead and sketch this right quickly for you. This is not neat, but that's okay. 4. 1, 2. This is the point 2, 4. And this is the point 7, 4. Let me just go ahead and do exactly what they have here. 7, 6, 5, 4, 3. We've got a horizontal line that's passing through 4 on the y-axis. And the 2 points that your book has given to us to use to calculate the slope are the points 2, 4 and the points 7, 4. So I'm going to label these point 2 and point 1, and I'm going to say that the slope is 4 minus 4, 2 minus 7. Our slope is 0 divided by negative 5. Whoops, what happens? When you divide 0 by anything, you still get 0. So we have a slope is equal to 0. It doesn't matter which 2 points I'm going to put here, because always in the numerator I'm going to have the difference of the y values, and the y is 4, no matter where you go on that line. So what do you see here? You see this is very, 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 very important. This is the slope of a horizontal line is always 0. For a horizontal line. In your notes, make a big asterisk, stars, arrows, hearts, lots of color. If you have a horizontal line, the slope is always going to be 0, because the way that you calculate slope is you divide the difference of the y values. The difference of the y values with a horizontal line is always going to be 0. Doesn't matter what you divide 0 by, your answer is always 0. Slope of a horizontal line is 0. Well, does that mean that the slope of a vertical line is going to be 0? Because the x values are always going to be the same. Well, let's think about that. And I bet some of you will have figured this out by the time I can even sketch something. Let me do 3, 4, and 3, negative 2. 3, 4, and 3, negative 2. Is that really going to be a vertical line? Let me sketch it for you. X is 1, 2, 3. Negative 2, 1, 2, 3, 4. We have the ordered pair 3, negative 2. We have the ordered pair 3, 4. And yes, of course, what we have here is a vertical line. Okay. That's the ordered pair where x is 3 and y is a negative 2. And we have a vertical line that passes through these points. Vertical lines always have the same x value. Well, what happens when we're doing slope? Isn't our slope the change in y divided by the change in x? You notice I changed from rise over run, vertical change, horizontal change, different ways of saying the same thing. What's the difference in our y values? I'll just pick this point here. 4 minus a negative 2 divided by 3 minus 3. The slope is 6 divided by 0? Is that 0? Is it what? No, remember our definitions. You cannot divide anything by 0. So, this is your very important thing to remember about the slope of a vertical line. slope of a vertical line is undefined. You cannot divide by 0. We say division by 0 is undefined. Since we're trying to divide something by 0, slope is undefined, or you can say that vertical lines have no slope. However, it's very, very, very important that you see there is a difference between a slope of 0, which is what a horizontal line has. It has no change. And a vertical line that has no slope. No slope and slope of 0 are two totally different things. So in my opinion, you're safer off until you thoroughly understand this, saying that the slope of a vertical line is undefined, the slope of a horizontal line is 0. That's all we have for section 6.5, and I'll see you next time.